Hello everyone, this is M. Tejasri. I am currently pursuing Integrated MTech Software Engineering and my registration number is 22MI0232. Today we are going to discuss about a case study called Linking Model Driven Development and Software Architecture case study. So, introduction. Model driven development captures design informal models using automated tools but lacks in empirical guidelines. This paper investigates applying MDD to large real world projects over several years. This reveals deficiency in modeling architecture designs rules within MDD approach. The literature lacks satisfactory solutions for modeling architecture rules and requiring manual practices. The formalizing architecture rules is essential for automatic enforcement and scaling the MDD projects. So, next slide, the role of architecture design rules. So, architecture design rules plays a crucial role in guiding and controlling the software design process to ensure that the system meets its quality requirements. And second point states that various architecture design methods such as ADD, attribute driven design, and RUP, Rational Unified Process, emphasize the importance of establishing an architectural vision to achieve desired system qualities like performance, modifiability, and security. Coming to the third point, architectures are typically represented as set of components organized into different views, focusing on aspects like development, structure, and runtime structure and resource usage. And fourth point says that research treats architecture design decisions as first class entities and lacks of formal modeling for rules on element types and constraint within subsystem. So, so the next slide says MDD and architectural design rules. So MDD captures design in formal or semi-formal ways. So the model-driven development aims to capture all essential design information in formal or semi-formal models and automatically maintain consistency between them using tools and reduces manual consistency effort through tools. MDD raises the level of abstraction for developers and reduces the manual efforts in assuring consistency among different design artifacts. And MDA uses CIM, which is also known as computationally independent models, and PIM, platform independent model, and PSM, platform specific model. While UML is used for modeling in MDA, other languages can also be utilized. And fifth point states that while MDA does not directly addresses the agriculture design, the architecture must be represented in models or maps. The modeling architectural design rules are ADL used to describe the architectures. So, the architecture description language, including UML, are used to describe the software system architects by specifying components like relations, interfaces, and constraints. Second one, lack of mechanisms for architect specified components. Component rules. And the modeling architecture rules like rules challenging like patterns. So, modeling architecture design rules poses a challenge similar to modeling the solution part of design pattern, as it involves specify specific rules to follow in the design process. And fourth one, limited formalization of rules in existing approaches. Existing suggestions for formally modeling design pattern specifications are limited in their ability to formalize rules, typically focusing on structural rules only. So, mathematical formalisms unfamiliar to architects or developers. And the research approach. And the case study research approach says that it combines the interpretivist and interventionist approaches for MDD. The research combines elements like interpretivist understanding and action oriented invention, focusing on investigation the application of model driven development in real industrial projects, particularly concerning the modeling of architecture and design rules. And it based on the combination of AB's industrial experience, means both industrial experiences and action case. approach integrating research perspectives. The research framework integrates positivist, interpretivist, and critical research approaches, adopting a hybrid approach known as action case approach, which involves in detailed analysis of single case to gain deeper sights and facilitate meaningful interventions. And the last one is 2-year project data, like rules, models, and process reviews, etc. Integrating architectural design rules in MDD project. First one, action case context. So, first one is project scope. It develops a software platform for digital TV set-top boxes and adhering to DVB standard within 18 months, meeting strict quality requirements and integrating with new customized hardware. The second one, project size, involved around 75 out of 250 Cambridge consultants, spanning over 24 months within three delivery milestones. And third one will be geographical distribution. Project distributed across 5 sites in southern Sweden with significant travel distance necessitating remote architecture support. And the last one will be customer relationship. We know that customer relationship is very important to companies had full responsibility for software development, but retained control over architecture, requiring negotiation and collaboration. Project challenges. The project faces several challenges like short time to market. Due to competition, the product needed to be ready by a fixed date, leaving limited time for development. And second one is parallel hardware development. Development of hardware and software simultaneously pose integration challenges, increasing the risk of errors and requiring testing across various platforms. And third one, moving requirements. The project dealt with evolving requirements while initial specifications were overridden by acceptance tests and delivered in late project lifetime. And the fourth one will be lengthy maintenance phase. The maintenance phase was anticipated to be lengthy and required to be cost effective, posing challenges in terms of resource allocation and sustainability. And the last one will be competition on performance and quality. Products were competing based on performance and quality, emphasizing the importance of delivering a high performing and high quality solution to secure the contracts given. So these are the 5 points that are faced during the project. So, rationale for choosing MDD. So, the first one will be efficiency. MDD was seen a way to automate the error prone process of implementing UML models, making the development process more efficient. And second one is agility. MDD, model driven development, promises to enable an agile approach, allowing quick progression from requirements to tested implementation without sacrificing documentation and crucial for efficient maintenance. And third one will be flexibility in hardware platforms. MDD allowed testing code without direct hardware access and generating code for different platforms as hardware become available, increasing adaptability to hardware changes. This The next one will be tool selection. Tool selection is an important phase where we select tools to implement on our project. So the first one will be it's required modeling in standard UML to minimize training needs and the needed code generation within good performance and target host and previous generation platforms. And the tool has to be the ability to debug at model level for efficient troubleshooting and the vendor's commitment to continuous improvement embedded real life system development. And the last one, the tool selected Rhapsody from Logix as it best satisfied all requirements with UML modifying automatic C++ code generation and execution framework for platform abstraction. So the process. The fall This followed a phased process similar to RUP, Rational Unified Process. So our project process also followed a phased process similar to RUP. Mm. Second point, the elaboration phase lasted 6 months and focused on architectural work by tool-led architectures. And the construction phase lasted for 12 months, involved around 50 developers, 7 teams implementing the design based on establishing architecture. And the component design review process by architecture team to ensure alignment with architecture, consuming significant architect time due to 166 total components. And capturing the architecture, there are different levels. First one will be high level structure, the architecture represented using UML packages and design rules documented in natural language, example component demonstrating adherence. And the second will be partition. In this, the architecture system divided into distinct layers including HAL, BSP, RTOS, etc. And it organizes and manages the system functionality. And the third one is component design rules. The architecture established guide component design, architect and architecture package with executable framework ensures consistency and adherence. And the fourth one is executable framework. This architecture includes abstract base classes defining core system abstractions, and this facilitates implementation and execution. And the last one will be documentation. Over 60 documented guiding architectural framework usage, and it covers component behavior and method overloading, etc. At last, coming to the conclusion, we can conclude that role of architecture design rules are crucial for software development, ensuring quality and guiding the design process. And the challenging of manual enforcement is error prone and time consuming, leading to stalled design and low quality reviews. The implementation for theory is further research needed to formalize and automate enforcement, making rules understandable and usable. The last one will be practical recommendations, allocate extra resources